For example, when a player makes a pass and someone on the opposition makes a block, it causes the acceleration of the ball to slow down dramatically. The reason for this happening is because a force is applied which is opposite to the direction of the moving ball, therefore causing the ball to decelerate. Impulse is simply a measure of the force applied for a specific time. To work out impulse, you do force times time. Impulse is important in sport because many techniques, particularly throwing activities, require the performer to apply as large a force as possible for as long as possible. For example, when completing an overhead pass in basketball, it is usually used as a way of getting the ball across the court over quite a far distance. To increase the impulse in the pass, a player could either increase the force put into the pass, increase the time taken to execute the technique, or do both. The more force a player puts onto the pass from the use of power in the arms and wrists will obviously increase the impulse. As well as this, a player can increase the time of the pass. What I mean by this is if the take back of the ball is further back behind the head, this will mean that there is more time to generate a greater force than if a player was to do a quick snappy pass from over the head. Both of these can obviously be used together to ensure that there is a high impulse generated in the ball and that it travels a far distance. So now let's look at momentum. Momentum is commonly used as a term in sports. You often hear commentators saying a team that has momentum is on the move and is going to take some effort to stop. A team that has a lot of momentum is rarely on the move and is going to be hard to stop. Momentum from a physics point of view refers to the quantity of movement that an object has. A sports team that is on the move has the momentum. If an object is in motion, on the move, then it has momentum. Momentum can be defined as mass in motion. All objects have mass, so if an object is moving, then it has momentum. It has its mass in motion. The amount of momentum that an object has is dependent upon two variables: how much stuff is moving and how fast the stuff is moving. Momentum depends upon the variables mass and velocity. In terms of an equation, the momentum of an object is equal to the mass of the object times the velocity of the object. So we're now going to move on to look at the method of data collection for the numerical model. When completing the method for the numerical model, usually some kind of video recording will take place as a way of being able to review the performance and take data on the performance after it's taken place. This is important because sport is so dynamic and fast moving nowadays, so as a tester you won't always be able to record all the data at once. When filming, it can either be 2-dimensional or 3-dimensional. Unless you are in a lab with high-tech equipment, like at a top football club like Manchester City for example, you will most likely be using 2-dimensional filming. 2-dimensional filming still does the job you need it to when analysing performance. However, it doesn't produce as detailed imagery and data like 3-dimensional filming does. However, though, the advantage of 2D filming is that it's quicker at recording the performance you are trying to capture. It's a lot faster to extract the relevant data from the images. It's cheaper and it doesn't require sophisticated software. And finally, when it comes to analysing the piece of filming, it requires less technical and mathematical knowledge. Like I've briefly mentioned, 3D filming will only take place in high-end sports labs and facilities and will be monitored by biomechanists with high knowledge of the maths involved in 3D filming to be able to produce effective and sufficient feedback. When you are collecting data, you have to think about different aspects in order to get the correct for your footage. This is because otherwise it could lead to not capturing the area that you are focusing on, therefore meaning that your data could end up being inaccurate. When collecting data, you should have a protocol to ensure that the experiment is consistent and reliable. If you were to take a retest, your results would be either the same or roughly the same. So I've already briefly talked about 2D and 3D filming, but there are a few other aspects that need to be taken into consideration in order to be able to capture and receive reliable data. Shutter speed and frame rate are a key element in ensuring that you receive a clear image. Shutter speed is the length of time your camera shutter is open, exposing light onto the camera sensor. Essentially, it's how long your camera spends taking a photo. This has a few important effects in how your images will appear. When you use a long shutter speed, you end up exposing your sensor for a significant period of time. The first big effect of shutter speed is motion blur. If your shutter speed is long, moving subjects in your photo will appear blurred along the direction of motion. You often see this effect used in advertisements of cars and motorbikes, where a sense of speed and motion is communicated to the viewer by intentionally blurring the moving wheels. However, when using shutter speed and capturing movement to be analysed, you obviously don't want a blurred image. Therefore, you will need a short and faster shutter speed to get a better recording. Frame rate is quite straightforward. The faster the frame rate means that it will produce a much clearer and smoother video. Obviously, when recording movement to be analysed, you need the clearest, smoothest possible video. Therefore, you'll need a camera with a fast frame rate to be able to capture this. Additionally, you need a high-speed camera to be able to film in slow motion, but not only film in slow motion, but to be able to film in slow motion which provides a clear image. So now going to move on to look at horizontal scaling, vertical reference, perspective error, and the field of view. So very briefly then, horizontal scaling is providing a scale of measurement that will allow you to convert on-screen measurements to real-life measurements. Vertical reference has the same principle as horizontal scaling, however it provides a scale of measurement in the vertical planes instead of horizontally. The field of view is very simply the area that you are recording that contains the sporting action. And finally, perspective error is an error where the person being recorded seems to get bigger or smaller on the recording as they move towards and away from the camera. This leads to you not being able to effectively judge their position and also monitor their movement.